Hello students, welcome back to the chemistry classes. Today we are going to deal with the third colligative property of solution, depression in freezing point. Freezing point of any substance is a point where its liquid phase is in dynamic equilibrium with its solid phase. At freezing point, vapor pressure of any substance in liquid phase becomes equal to the vapor pressure of that substance in solid phase. According to Rolle's law, whenever any non-volatile solute is added to any solvent, its vapor pressure gets reduced. As a result of this, that solution has to be cooled up to a lower temperature to make its vapor pressure equal to that of solid solvent. That's why its freezing point also gets reduced. That we can easily understand through a graph plotted between vapor pressure versus temperature. On reducing the temperature, vapor pressure of solvent decreases along AB. At point B, the solid phase appears for the first time. Temperature corresponding to point B, that is T0 F, it is the freezing point of pure solvent. Now when we talk about the vapor pressure variation for a solution, we see here that the vapor pressure curve of solution lies below the solvent as it has a lower vapor pressure. Now when the temperature of solution is lower, its vapor pressure further decreases along DE. At point E, this vapor pressure curve meets with the vapor pressure curve of solid solvent. So temperature corresponding to point E, that is TF, is the freezing point of the solution. So from the graph it is clear that this freezing point of solution is lower than the freezing point of pure solvent. So this difference in the freezing point of pure solvent and solution, so that difference is known as depression in freezing point. We can write it, the depression in freezing point delta TF, that's equal to T0 F minus TF. Also we shall know that the freezing point of any solution depends upon the concentration of solute, but it is independent of the identity of the solute. Here also, just like elevation in boiling point, the depression in freezing point also is directly proportional to the molality of the solution. We can also write it as delta TF is equal to Kf into M, where Kf is known as freezing point depression constant or molar depression constant, also known as cryoscopic constant. Its unit is Kelvin kilogram per mole. Unit of Kf is Kelvin kilogram mole inverse. Now suppose Wb gram of solute is present in Wa gram of solvent. Then its molality can be written as Wb into 1000 upon Mb into Wa. So we can write delta Tf is equal to Kf into Wb into 1000 upon Mb into Wa. Using this formula, we can easily calculate the depression in freezing point for any solution. Now let us see a numerical based on this topic. Now here is your question. Calculate the mass of ascorbic acid, that is vitamin C, that must be dissolved in 75 gram of acetic acid to reduce its freezing point by 1.5 degrees Celsius. Kf for acetic acid is 3.9 Kelvin kilogram per mole. So we can start the solution with the given quantities. Here mass of solvent, that is acetic acid, Wa is equal to 75 gram. Depression in freezing point delta Tf, that's given 1.5 degrees Celsius. Molar mass of solute Mb, that we can easily calculate using its molecular formula. For carbon 12 into 6, for hydrogen 8, and for oxygen 16 into 6. On calculating you will be getting it 176 gram per mole. Same way Kf value is given here 3.9 Kelvin kilogram per mole. Now, by using formula, delta TF is equal to KF into WB into 1000 upon MB into WA, we can calculate WB is equal to delta TF into MB into WA upon KF into 1000. Now on substituting all the values, delta TF is given here 1.5, MB we have calculated 176, WA mass of solvent, that is 75, KF is here 3.9 into 1000. On calculating, you will be getting it 5.077 gram. It means 5.077 gram of ascorbic acid is required here. In this way, we can calculate the molar mass of any unknown solute or depression in freezing point by solving different examples related to this formula. Now we will discuss about few of the applications of depression in freezing point. Now here are the two main applications of depression in freezing point. First, antifreeze solutions. We all know that water is used in car radiators as a cooling unit. When the vehicle is used in cold countries or at high altitudes where temperature is always below 0 degrees Celsius, so there are chances that water may get freeze inside the car radiators. To prevent it, a solution of ethylene glycol is added to water in the radiator. Ethylene glycol acts as an antifreeze agent and it reduces the freezing point of water so that it may not get freeze inside the radiators. The second application is here, clearing of snow from roads. Salts like sodium chloride or calcium chloride are scattered over snow covered roads. These salts reduce the freezing point of snow, as a result of which the snow melts off. So apart from these applications, you all can practice some more examples related to depression in freezing point. In our next class, we will discuss about the next colligative property, that is osmotic pressure. Thank you.